start. Sorry for a slight delay, but as always, technical stuff is problem for engineers. But we hopefully resolve all this problem. Okay, so in the behalf of Virtus Lab, sponsor of the today event, I want to say a warm welcome to everyone in this room, but especially for our speakers, Jakub and Michał. Before I give them the stage, I want to say a few small things. I mean, first one is Lambda Days. I hope you heard of that conference. Is looking for speakers. So if you have an idea, write them an email with the abstract and bio. They will be they're looking for anything interesting around functional programming. If you are interested in functional programming, but you don't want to have a presentation, you can buy tickets for that conference. It's early bird, and you can save some money if you are interested. And the third thing I want to say is that I want to inform you, or probably present, that the next Scala Sphere conference will take place in March next year. And so I hope that you know what Scala Sphere is. If not, it's like a conference around Scala tooling. And so if you are interested, reserve your time. Last thing I want to say is that today's presentation will be recorded. So if you have friends that's interested in what we will be speaking today, please share so they can see this amazing presentation that we are about to see. So the first one is Jakub Kozłowski and his talk about macro sorcery. So I hope that it will be rocks your world in the programming in Scala. So I'm giving the stage. So loud applause for Jakub.
Okay, so can you hear me in the back? Good. Okay, so I've been introduced already, but you don't know that I work at Scala C as a Scala developer. Well, now you do. So you've seen this title and probably thought, what does it even mean? And the secret is that it doesn't mean anything in particular, but it's meant to sound weird. So if you have heard about macros from anyone, you will probably have heard that they are something weird and difficult and like black magic. So I can tell you that it's not that bad. And you'll see. I'll show you why. So our plan for today is we'll go through why we are actually here and why we should care about macros, what they are. Then we'll spend some time coding, hopefully without any errors. And then we'll spend 5 minutes on summarizing what we've learned and just summarizing. So I like asking questions. So my first question to you is, who are you? But not in the general way. I wanted to ask you how many of you are Scala developers. Raise your hand if you are. Okay, so almost all of you. That's good. But if you are not a Scala developer, please don't leave. You're going to learn anyways, if you want to, of course. And I hope that all of you are developers of some sort. Yeah, I guess. So why are we here? That's the question I'm going to answer this time. So as you've noticed, everyone here is a developer, and I am a developer too. As developers, we want to write good software without bugs, without problems. And I know all of your programs are, of course, perfect and don't have any bugs ever. But if that happens, that one time in a million, then you need to learn something. So to write better software, we want to learn. We need to learn. So we are here to do just that. And we are going to learn 3 cool things The first one is how to avoid writing boilerplate, because nobody likes writing boilerplate, right? The second thing is how to to avoid runtime overhead, because that's something nobody likes either. And the third thing is, well, this time there will be no avoiding, we'll be actually adding things. So we'll be adding additional static checks. So avoiding bugs, in essence. And what's common about all these things is that we're going to do that with one thing. Can you guess what it's going to be? The first person to answer gets a t-shirt. Yes, exactly. So I have 3 more t-shirts. Come pick them up later. If you have a question, by the way, please raise your hand and ask it. You'll get a t-shirt or something else. Okay, let's go on. So yeah, we're going to do that with macros. Surprise. And what are macros, right? Because nobody knows, of course. Neither do I. No, so most of you have probably heard a thing or two about macros, but maybe you don't know what they are. Maybe that's why you're here. So to make sure we're on the same page, let's go through some description. So macros are one of the tools that enable metaprogramming. So when you are programming, you're writing code, right? And when you are metaprogramming, you're writing code that writes more code or deletes code. So it codes, but after you code it. So yeah, code that writes code. And all of that writing by the macro happens during the compilation of your code. So it's not really like reflection or some other ugly tool. So there are a few kinds of macros in Scala. Yeah, because all of these apply to other languages as well. This is why it doesn't really matter if you're a Scala developer or not. But in Scala we have a few kinds of macros, and there are 2 kinds of them which are the most popular, which I'm going to describe now. The first one is an annotation macro. So it's used, surprise, like an annotation, which looks basically like this. This type class annotation comes from Simulacrum, I think, a library for generating code for type classes. So what an annotation macro can do, it can add methods to your class or some other stuff to your class or object or method, or completely modify it. And it currently only works if you add a compiler plugin, which is Macro Paradise. But it may change in the future versions of Scala. What's different about annotation macros compared to normal annotations is that, well, all of the magic that's happening occurs when you compile this class, this trait, not in runtime. So it will, if you do something wrong, it will fail immediately. So it's less error prone than reflection. And also, if you go to the definition of the type class annotation, you'll see what it does straight away. So you won't have to search for some annotation processor which does all the magic or whatnot. Now the second kind of macros, which is a def macro. Def is a keyword for creating functions in Scala. So again, surprise, these macros are used like functions, which looks basically like this. So this is a cache macro, which makes sure that you don't call an expensive service or something more often than, in this case, 15 minutes. It's going to be cached every time you run it. You're going to get the same result until 15 minutes pass. And what's different about this compared to functions, normal functions, is that it can transform its arguments ASTs. or analyze them and then transform them. And yeah, what are ASTs, right? So an AST is an abstract syntax tree. So the name may be some kind of well, you may guess what it is by the name. So it's a syntax tree, so it's the representation of language syntax. That's how it works in compilers. So all the code you write is at some point visible as a tree structure. And it's abstract because it's independent of concrete grammar. So an AST doesn't care if you use infix notation for method calls or dot notation like in Java. It's not kept, but it's going to change in Scala Meta, which is the successor of Scala macros. It's going to keep all the information because that's useful for some reasons. I'll tell you more later. But it will still be a bit abstract. So what an AST looks like, if we were to draw one, is something like this. So this is an AST corresponding to a function application. So on the right side, this list is just a normal Scala list, not some compiler stuff. So an apply block has the receiver, the thing you call the method on. No, sorry. Then there's a method. It accesses the method by the left side. So it looks by an identifier, which is a term apparently called println, and it has a list of arguments on the right side. So there is only one, which is a constant with a value hello world. So basically, this whole tree corresponds to this line. So you may be already worried that it's actually quite a lot of blocks for something very simple, like trivial. Now, we know what ASTs are. Let's take a look at how macros can help us. So these three things we're going to learn today. The first one was avoiding boilerplate. So I'm afraid all of you know what boilerplate is, but in case you haven't, you didn't have the occasion to write any, I'll give you a short description. So boilerplate is essentially the code that you need to write because you cannot generify your code more. You have to repeat yourself sometimes. And a quick example. So if you want to convert a class to JSON without using reflection, then you need to do something like this. Well, we have a person instance, and we want to convert it to JSON, and later, let's say we want to convert some JSON to a person class. So really simple, right? But if we don't want to use reflection of any kind, then we are forced to write something like this, or use some implicits, whatever. Anyway, so you need to write the names of the fields and connect them with the values of the fields. So it's really a lot of code for something trivial, right? Something you don't want to write. So this is the essence of boilerplate. Now, how macros can help us with that? Well, with macros, with the write library, you can just do these 3 lines, and you don't really need anything else. So these 3 lines are all. Maybe you need one more import or something, but yeah, you need to import the toJSON method, but that's all. So that's the first example. Now the second one, the second example of boilerplate. When you want to update a field, like nested in a class. So we have these 2 classes, a person, which has a name and an age, and an address. And the address class has a street, a city, and a postcode. So imagine that we have this person, this Joe, who's 18 and lives in NYC. Let's say we want to change his street number, or his street name. So in vanilla Scala, you would need to write something like this, right? And it doesn't really look good. And in fact, it reminds me of this, which is some PHP code. Don't get me wrong, I have nothing against PHP. It's a beautiful language. But it doesn't look good, and there are hundreds of ways to avoid that in PHP, not in Scala. So we generally don't want to write that kind of code. Now what's the solution? We can use a data structure called lens, for example, from the shapeless library, which has some useful stuff, some really useful stuff, but mostly if you are creating a library. Anyways, we can use that. So we have the same code as before. We import shapeless. We create a lens of type person, and we treat it like a person. So we go to its address and its street, and then we just call modify on it. We pass in the person instance we want to modify, and a function that changes the street we were selecting just before. And it doesn't change the original person. It just creates a new copy, if that's not clear. And again, that's all. It's basically 2 lines of so-called boilerplate. So I think it's good. Anyways, that's good for you. The second thing I wanted to tell you how macros can help us with is avoiding runtime overhead. So as an example, we use creating a generic array of elements. So without macros, you would need to write something like this, because you needed a class tag to create an array of type T. So what's wrong about this code is that it uses boxing for if you create an array of primitive types. But you can fix it, right? You can make use of specialization. If you don't know what that is, it's basically the specialized annotation will make sure that bytecode is generated for every primitive type for this function separately, so that there is no boxing. Because in Java bytecode, you'll see that this doesn't accept a generic type, but some int, some double, some boolean, and yeah, it won't use boxing, so it's cool. But it still has some disadvantages. For example, because it's viral and heavyweight. So what this means is that all of the call chain of this method will be specialized as well. And getting 10 versions of the same method isn't really cool for your jar size, for application size. And if you have more than one type parameter, then you're going to have a really bad time, because that's 10 types for every type. So if you have 3, then you have 1,000 versions of the same method and everything inside. So again, it's not a silver bullet, but you can do it by hand. You can handle the primitives manually. So we can just match on the class tag, and if it's an int, you can call some function with an int specifically, or some other primitive type. So that way we will avoid boxing, and it's all cool, right? But where the 3 dots are, you would have 9 other lines, which look basically the same. So again, it's boilerplate. And now the solution, the ultimate solution, which is not the ultimate solution, but it's still better than writing this by hand. So you can use macros again. And with macros, you can create a specialized macro, which will do what we just did on the previous slide with matching on the class tag, but you won't have to write that every time you call such a method. So it'll be reused. It will be just written for you during the compilation. So yeah, it'll generate specialized code, and it won't pollute your whole function with copies. Now the third one. I wanted to mention that Dotty will have something amazing for this. This example will be irrelevant because Dotty is going to have something like automatic specialization. So it'll analyze which types you are actually using for this function, like the first one, the first version of createArray. And it'll generate only the bytecode for these types which you're using. If you don't know, Dotty is the future of Scala. Okay, and now the third one, adding additional static checks. So I'm going to ask you a question shortly. What kind of additional static checks we want to add? For example, we want to avoid unsafe behavior in our code. So a question for you, what's wrong with this code? It's from some actor or something.
Sender is a mutating call.
Yeah, exactly. So sender can change while we are executing in the future.
The signature of the sender currently is not this. It has a brackets on it.
Well, you don't need to use them.
Warnings and compilation.
Yeah, of course.
It's very showing that it's not safe.
Yeah, it probably is, but you won't get an error if you don't have a flag for compiler warnings errors. So it's unsafe because sender can change while you are executing the transform function, because sender is just the sender of the last message that came to your actor. So sometimes you won't notice this. It's of course not something you do every day, like such a mistake, but beginners can have this kind of problem. So sender can change, as I said, and we can avoid that kind of stuff with macros. How? So we are introducing a spore macro, which is going to accept a body that's just a function that will complete with some result, some value. And what it generally does is it makes sure that you don't use any free variables or mutation inside, so that your code will be safer. So you can't do that without macros, but with macros you can. So it'll just throw an error if you try to do that. Okay, so we can see what macros can help. Of course, how macros can help. And we more or less know what they are. Now let's see how to write them. So we need to set up some things. First of all, we need to have this dependency in our SBT file, or just import the jar. We need to keep in mind that to use our macros, we need to compile them before we use them. And I'm going to describe some ways in a second. And we need to import some scary black box or white box. So this will enable, it'll give us a class called context we're going to use for everything related to macros. And there are two kinds, so black box or white box. The difference will be on one of the next slides. And if you want to use macro annotations, then you need a compiler plugin. So how do we compile before we use our macros? So the first option is just use SBT console for quick prototyping. We are going to do that today. We can as well create an SBT subproject, one for macros and one for the code that uses them. So that will make sure everything's in the right order. We can also create an external module in our IDE, or just build a jar with our macros and import it, or import it from Maven or whatever. Yes, please.
There's one more way. In Scala, you have a special scope for compilation called macros that is compiled before all the rest of the class. So it's emulating exactly all these four, but you have one project. And it works only in Scala IDE, right?
Yeah, probably. So yeah, so you have that. It's going to get better with Scala Meta, I think. So it shouldn't be as problematic. Okay, now WHITEBOX versus BLACKBOX. What's the difference, right? So BLACKBOX means that if you specify a type on your macro method, then whatever comes out of it is exactly of that type. But if you use a WHITEBOX macro, your macro can return something more specific, some more specific instance, and the type will be still inferred in your in the method. And it's considered unsound or unsafe. So this option is going to disappear at some point in the future versions of Scala. So yeah, with WHITEBOX you don't need to stick to the concrete type. You can have something more specific. Now, what does a simple macro look like? Here's a quick example of a macro that basically replaces the hello call replaces it with println hello. So you have quite a lot of things here because you need two methods actually. You need to have a context parameter in every macro you write, and you need to import the whole universe and use some reify method we don't really know yet, but we are going to find out what it is. Okay, so now let's code. We're going to write a macro that transforms a function, like a mathematical function, into its derivative. So let's say we have this kind of a function. So it's and we want to derive it. A derivative of a function, for those of you who don't know, is just the if you have a graph of your function, then it's basically oh shit, I forgot to explain that. But anyways, it's some kind of mathematical transformation, okay? So you can trust me that the derivative of this function is going to look like this. And let's do that. So give me a second to set up. Okay, so you can see the code, hopefully. All right, so here are two simple macros that I wanted to write before we go to the more advanced one, the mathematical one. Shit. Yeah, of course. So the first one, the hello macro, is going to work something like this, like hello here. So, but it's going to replace the original call with what's inside. So, yeah, but first let's write get code, which will print the code of whatever you pass inside to it as an argument. So, yeah, because it's going to be a macro, you need to write macro. So get code impl. Let's write that. We need the context from BLACKBOX and an expression from the context of type any, because it's any here. And we return an expression of type string. Now we need to import CUniverse. We're going to do that a lot. And yeah, there are a few useful methods in the universe which help us understand what's inside our expressions. So we can, yeah, let's just return something like that. I hope it's going to compile. And let's see what we get as an argument. So we'll use show code for that. It expects a tree, so let's get the tree from the expression. And let's run that. Yeah, it fits, okay. So let's start simple macros. Get code, hello world. Okay, so it did print the print line, but you know it's what we get after desugarizing and all that stuff, so it's not really specific, but it's good enough. We also have show row, which will print the representation like on the graph I showed you before. So let's see it. Yeah, of course, the import. And it's quite a bit longer, as you can see. But we can use that to construct or deconstruct macros. Okay, so we wanted to return that, return what we got here. So let's say our A code will be show code of A3. And let's return, yeah, we want a string, so let's just create an expression. And we'll use something like that. I'll explain it in a while. And I hope it's going to compile. It definitely should. Okay, so get code worked. We have the value as a return value, so not anything magical. But let's see hello 2. So, yeah, again, we need macro, hello to impl. The hello to impl is going to have a black box context. An expression, sorry, it's S this time, and a string. And we don't need a type. So again. Okay, and now let's actually use reify. I'll explain it in a second. And we'll do print line hello as splice. Okay, so let's see if it works, and I'll explain. No, now it's hello to world. Okay, so it works. Now, what's the difference between hello 2 and hello normal, right? So we can use get code for that, and we need to import this. Import step 1. Okay, so get code of hello world. Yeah, so we can only see that there's, you know, that hello wasn't replaced by anything. It's just a call to the hello method. But if we do it with hello 2, it's going to be a print line here with some complications, because that's how things work. Okay, so now what did we actually do? So reify is just a method that creates an expression out of whatever code you pass inside, but it's kind of magical because you can use a splice, and splice is a method that basically replaces, you know, itself with the actual value of S, the way I see it. Yeah, and you can only use splice in a reify block. So that's one way of creating new expressions. There are some other ways, which I'm going to show you from code that I have already written because we don't have much time. So yeah, we did this, but we can also use quasi-quotes, so something like that, which I think I showed before. So yeah, this is kind of scary, but it works. So Q basically creates a tree. So the difference between a tree and an expression is that an expression has some more information about what you pass inside. But yeah, that's the difference. So yeah, so with the interpolator we can, write some code that will be basically pasted instead of our macro call. And yeah, we use the tree of S here, and it generally has this almost the same effect as with FreeFI. And we can also construct the tree manually, but it doesn't look pretty, so it's really long, surprisingly. But you can use that if you want some more type safety while writing your macros, because this doesn't really have any, syntax highlighting or whatever. You can probably do that in Scala IDE, or maybe not. Yeah, so there are problems in every IDE, but it's going to get quite better with Dotty, I'm pretty sure, because they are going very fast. Okay, now we can probably go to the final example here. So I've already written the basics. Yeah, so we are going to derive a function from double to double because we don't have much time. So again, macro derive impl. Let me just write the boilerplate. Okay, now what does a function tree look like? And yeah, I haven't showed you a very useful feature of quasi-quotes or the trees, because if you put some apply or something on the left side of your expression, you can pattern match on it, or you can just, pattern match on it. So we're going to do just that. So we're going to extract the body of the function we are passing inside. And that's how we do it. So we'll have F3. We have some arg, probably. And we'll have some body. As simple as that, hopefully. Again, we need to return something. So for now, let's return the original function. And let's see what this arg is, actually, because we are going to need that. So let's compile again. First step to macros. And that's derive. And let's just use something like that. Okay, so again, this is after desugarizing. It doesn't look pretty, but we need to live with that. And to extract the name of the argument, we need to do some more matching. So we'll do yeah, I think we can do val arg name. And we have the type we don't need actually. Yeah, there are some modifiers here, I think. Or maybe here. And let's see if it works. Yeah, no. Okay, I need to cheat a bit because I really want to save time. And it's here. Okay. Yeah, the modifiers are of course on the left side. So it compiled. Do we print anything? Yeah. So let's see what the argument name is. Of course we need to import. It's eggs, of course. So let's think what we want to return. So I think we are going to return an expression with a tree that looks similar to this one, but with the replaced body. So we'll do result here on the right side, and we'll take an argument which is basically arg name. But for some reason we need the type here. Okay, so it should probably work if we have a result. So let's create a result. So it's going to be, yeah, to derive our function we need to first convert the trees and magic to something we understand and we can work with. So let's do like extract component from the body, and then we'll derive it and convert it back to a tree using the context from here. Now let's define extract component. Of course, it needs to take a tree. And yeah, the component trait is going to look like this. It's going to have a method for deriving and a method to convert it back to a tree with an implicit context. Okay. Don't worry about the type errors. They are just in IntelliJ, it's probably going to compile normally. I'll make sure. Yeah, it compiled. So let's do this. So we can match on the tree. And yeah, what kind of functions we can expect? So we can definitely expect adding to elements. So we are going to replace that with an addition, which doesn't exist yet, with components extracted from these values. So let's define addition. Yeah, no, let's not implement this yet. What's wrong here? Yeah, of course, we need two components here. Okay, it more or less looks good. Yeah, then we can have multiplication. That's the basics. That looks basically the same, so we can actually copy it. And we need some building blocks, like very, very basic building blocks. So we need a reference to a variable and a constant. So I don't think we can use quasi-codes for that. I've tried and I didn't succeed. So I'll just use ident term name, like with trees, with some name, and we'll make that a variable. It's going to have a name, yeah, and it's still a component. And a constant, so that's literal constant b. And yeah, that will be a double constant. And we want to make sure that it's a double, so don't do this at home, but I'm going to do this to string to double. Okay, let's do that. Can you see the code? Oh shit. Why didn't you tell me? Okay, so let's have a double constant with a value. What's the name? Yeah, let's call it b. And I think it's all right. So let's try to compile that again, just to make sure. Yeah, something's wrong. Of course, we didn't implement anything, but otherwise, I think everything is fine. So let's think what we should do. So let's do to3 first. So yeah, again, we need to import everything. Yeah, no, we need a tree, so just q a to 3. This is why I used implicits for that. So we basically write the same thing we used to pattern match before. And again, here, the same thing. X. And again, for the last time. Okay, now let's try to derive all those things. So you may trust or not trust me, but the derivative of an addition is basically an addition of the derivatives. So we'll do just addition, A derive, and B derive. Yay. It's quite more complicated with a multiplication, because now it's an addition of multiplication of the first component and the derivative of the second one, and vice versa. So A derive and B. It's probably all right. A derivative of a variable is very, very simple because it's just one, always. And deriving a double constant is 0. It's going to work, I hope. Okay, so I think it should work for the cases we support now for addition and multiplication. So let's try that. Step 2, macros. So let's have something like 5 times x plus 4. So the derivative of that will be 5. Let's see if it is. So for every input, it should be 5. So you can believe me, it is. We should probably be able to do some more complex stuff here. Yeah, so that would work too. Now, this example we used in our, sorry, not this. Yeah, in our slides is quite a bit more complex. And I don't really want to write all that stuff, so you'll probably excuse me for copying this. Yeah, well, I'll just use the final version for that. So this is step X. We added a few kinds of components. So we have a single plus and yeah, what's the name? The unary plus, the unary minus, subtraction, and explanation. But yeah, it looks really weird here, but it works. So how it works in the derivative is that, well, I really don't want to explain that now. There's not enough time. But you can believe me, it works. Yeah, so maybe a short formula. So if you have a times, x to the power of n, then the derivative of that is n times x to the power of n minus 1. But it doesn't work if n is 0, so we have a guard against that. But in other cases it does. And the 2-3 looks basically the same as the matched version. And the others are trivial, we can check out the code later. So let's see if it works with the sample we had here. So, oh sorry. So now let's go to the console, import step X macros. And that's, yeah, let's see. Of course, we need to do some bad stuff. It should work. Oh, of course, we need a function, not an expression. So you can see that it doesn't really look pretty, but it's going to have the same value as this function. So minus 4x minus 8. So let's see. So our derivative was inverse 1. So for 5, the result should be minus 28. And yeah, it is. So it works. Let's see it for 2. So for 2, it should be, sorry, let's do it for minus 2. So that would be 0. No, it's not 0. So minus 2 times minus 4 is...
It was for 0, not minus 2, so it's okay.
Hmm?
It was for 0, not for minus 2.
All right. Yeah, it works. It's a minus 0, so macros are cool. Okay, so let's go back to the slides because this is dirty code. So we've we've finished the demo. Now it's time for our conclusions, our summary, like real quick. So we've seen some bad parts of the code of macros. And the first one is that it's an opportunity for writing very hard to read code, hard to write sometimes, not always. So yeah, it's a good way to piss off your coworkers if you want to. And they are basically type-safe code generation. So in some cases, it may be problematic to work with them because of that. And it's still code, it's not magic, it's not a silver bullet, so it can still have bugs like normal code. It also improves the compilation time of your programs, which is not really a good thing in Scala because it already takes quite a bit of time to compile anything in a bigger project. And it's not trivial to debug because you can't really connect to the, I mean, you can connect to the compiler, but you probably don't want to do that. And yeah, because it's a very powerful tool, you should use it with responsibility and not do anything weird with whatever you get inside your macro. But there are not only the bad parts, there are some good parts as well. Less of them, but still. So macros can make your code, your client code, simpler and safer. But you know, with sacrificing the code that you need to write beforehand. And it's trivial to use for clients, unless they have some bugs, right? And it's not rocket science to write them, because I kind of learned to write them, and you can too. You probably know how to write them already, after this talk. Now, how does the future look? Like, really quickly. So macros will not be there in future versions of Scala, like this kind of macros. So we shouldn't have come here. No, just kidding. So macros in the way they look like now are going to be dropped, but they're going to be replaced by Scala Meta, as I said before. So it's a new thing. And it'll be easier to write them, like way easier without all the boilerplate that I had to write every time I did something. It's going to have better tuning support. For example, in IDEs, you'll be able to just click a macro usage and expand it in place to see what it evaluates to, and you won't lose all the information like dots and spaces. And WHITEBOX macros are going to be done. Some libraries use them a lot, and the creators of them still don't know how they're going to survive that. But I'm sure they are going to find a way. For example, Quill, which is a library for type checking your SQL, or well, it's something like Slick for accessing databases, but it validates your code against the schema of the tables you are using in your database. It's pretty cool, but it uses WHITEBOX macros, so the future is not very clear for that. And yeah, Dot is going to have a really cool feature, so that's kind of related to macros, but not completely. You'll be able to define some conversions of the client code of your library. So, for example, if you are the author of Akka, you'll be able to define some code that, for example, if you try to compile send in the future, you will get an error during the compilation or something. Or you can do something like, if you are the author of the standard library and you want to avoid cases where people call stream.length is more than 0, you will just be able to define a transformation from that to stream.nonempty, something like that. Of course, if it doesn't have any side effects or something. More of that in a talk I'm going to link soon. So now the big question, should you use macros? And my answer is yes, definitely you should use them, because they can reduce the amount of time you spend on some ugly things. But should you write your own macros? So that's a question that I don't really have an answer for. But the answer that's closest to the truth is only when you absolutely need to. So not really. Now the summary, what we've learned today. We've learned what macros are, how to write them, how they help, and how they can cause problems with your code or real life. Yeah, that should have been before. Now here are some links. So a more detailed introduction with the same derivative example, but as I said, more detailed. The source from some examples by Eugene. He's a guy who's behind all the macro stuff in Scala. Not only him, but mostly him, I think. And he's working on Scala Meta now. And if you want to learn more about Scala Meta, check out this talk from Scala Days Berlin. I think it's the newest version of this talk. And the last one is on Linker, so the rewrites in libraries. And I think that's all. So thank you for coming and listening to me and surviving my live coding session. Now it's time that you can ask questions, and I really recommend that you do, because I think we have 1 or 2 more t-shirts to give away. So what are your questions?
I have a question.
Yes, please.
Can you test macro implementations? Like, can you unit test them?
Yeah, you can test the implementations, but in another module. So, yeah, just like you would use them, you can test them.
Yeah, but you have to supply like a part of the abstract syntax tree.
Oh, so you mean like you want to test if the macro returns some kind of tree, concrete?
Yeah, not unit testing the code generated by
the
macro, but the macro itself.
Okay, so I'm not sure. I think you can't do that.
Okay.
You can use Toolbox, but Toolbox is not the same as because Toolbox is some kind of runtime compiler for Scala, but it has slightly different universe.
Oh yeah. So I don't think you can do that now. Maybe it will be possible in Scala Meta. You can submit an issue for that, or a pull request.
Thank you.
Yeah. Okay. So any more questions? Okay, fine. So if you actually have any questions in the future, yeah, you can see the slides here on this website. The code is on GitHub. You can contact me if you have any questions afterwards. So my Twitter handle, my email, and some other means of contact you can find on my website. And on the last slide, I'd like to invite you to the Scala Wave conference, which is going to take place in late November in Gdańsk. It's organized by Scala C. And it's going to be a very cool conference. I recommend that you go to the website and see what speakers we're going to have. There are going to be workshops as well. So, yeah, that's all. Thank you.